Hi everyone, so this is our second video on static electricity, and in this video we're really going to be focusing on the charging methods. And to help us with this, we also have Greg, our science dino, and a special guest to help us. So yes, our special guest to help us with static electricity is Shaun the Sheep. I am not the creator of Shaun the Sheep. All of that goes towards Nick Park, who is the British animator and director and creator of Shaun the Sheep. Shaun the Sheep, I'm just borrowing him today to talk about our 3 charging methods. So let's get started. Our first charging method is by friction. Now, friction is the action of rubbing 2 objects against each other. Now, when you are charging by friction, both objects start off by being electrically neutral. So they're both electrically neutral in the sense that the wool has an equal number of electrons and protons, and the glass rod has an equal number of electrons and protons. So as we see here, our wool has 4 protons and 4 electrons. Our glass rod has 3 protons and 3 electrons. So to charge, we're basically rubbing the 2 materials together. And as a result of that friction, we have one material that gains electrons and one material that loses electrons. One thing that I really want to highlight, the number of protons always stays the same. So the wool became electrically negative because it gained electrons from the glass rod. It still has the 4 protons that it started with, but it gained 3 electrons from the glass rod, making it overall negative. The glass rod is electrically positive because it lost its electrons. So what happens is that the wool takes electrons from the glass. It's acquiring a negative charge. The electrons leave the glass and go to the wool, acquiring a positive charge. But the protons never move. It is only the electrons that move. So to summarize, 2 neutral materials are rubbed against each other. One takes electrons from the other. So the material that takes the electrons has a negative overall charge. The material that loses the electrons has an overall positive charge. Now, to figure out which materials are gaining and losing electrons, we use something called our Triboelectric Series. So a Triboelectric Series is basically a list of substances. And based on the position of these substances, it lets you know when you rub them one with another with friction, which material obtains a positive charge and which material obtains a negative charge. So if I'm looking at this small Triboelectric Series chart that I have right here, I can see that the top of my Triboelectric Series are materials that are going to be gaining electrons. The bottom are going to be materials that are losing electrons. So let's say I am rubbing vinyl with paper. So to figure out which one is going to acquire the negative charge and which one is going to acquire the positive charge, I basically look at its position on the chart. I see that vinyl is closer to the negative charge end, so vinyl is going to acquire a negative charge, and paper is closer to the positive charge end, so paper is going to acquire a positive charge. Now, what's really important with our Triboelectric Series is that the which material is positive and which material is negative is situation specific. So what I mean is the following. Let's say in our next charging by friction, we rub paper with glass. Now, based on this setup, I can see that glass is closer to the positive end than paper is. So paper, in this case, will take electrons from glass, acquiring a negative charge, and glass will lose electrons, acquiring a positive charge. So whenever you are charging by friction, you always need to actually look at your triboelectric series to see which material will be losing electrons and which material will be gaining electrons. Our second way to charge items is charging by conduction. Now, what differs between friction and conduction is that in friction, both items are neutral to begin with. When you are charging by conduction, one has to have a charge. The other object is neutral. So in my example here, I have charged wool, which has a negative charge, and I have a neutral object here, which is a metal sphere. And if we can see, the wool that Sean the sheep is holding has 2 protons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So it has an overall negative charge. My neutral sphere, I can see that I have 3 protons and 3 electrons, so it is neutral. So when we are charging by conduction, the charged item touches the neutral item. And what happens is that I have a shared charge due to this contact. I see that my neutral item gained electrons, my charged item lost electrons. But what's really important to remember is that now both share the same charge in the sense that both are now negatively charged. So if I look at my wool, I still have my 2 protons because remember, my protons never move. And I have 1, 2, 3, 4, 5 electrons here. So my wool is still negatively charged, but it's actually weaker than what it started with. Why? Because it shared some of its electrons to the neutral object. The neutral object is negatively charged because I see it still has the 3 protons it started with. And it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it gained electrons here. They're both negatively charged, but the charged item is weaker than it was before. This also happens if I have a positively charged object that is touching a neutral object. It is going to be gaining electrons from the neutral object, and both items will be positively charged. Same thing is in the sense that the object that was already positively charged will be less positively charged than before. So when we're charging by conduction, to recap, you have one charged material that touches a neutral material. The result is that the charged material gives approximately half of its charge, so it's overall weaker, and they both are now have the same charge. The last charging method is charging by induction. So similar to conduction in the sense that I have a charged item and a neutral item. But in induction, the charged item does not touch the neutral item. It only gets close to the neutral item. So we see that the charged wool gets close to the metal sphere, but it is not actually touching the metal sphere. And what happens is I have the rearrangement of my charges, and I have a dipole in the sense that my material, one side of the material has one charge, one side of the material has the other charge. But if I look at it overall, it's still net zero because I didn't gain or lose any electrons here. All that happened is that my charge is rearranged. Because my wool was negatively charged, my protons shifted closer to where the wool was, and my electrons moved away. The same thing would have happened if Sean was holding a positively charged item. If Sean was holding a positively charged item, then that means that all of the electrons would shift towards the positively charged item, and then all of the protons would shift to the other side. So again, with induction, I do not touch the item, but the charges in the neutral substance rearrange. The net charge in both remain the same. My wool is still negatively charged. I haven't lost any electrons here because I didn't actually have that physical connection to touch and transfer those electrons to the other object. And my neutral substance is still neutral because I still have the same number of electrons and same number of protons. The only thing that's happened is that one side has all of my positive charges and one side has all of my negative charges. So to recap, a charged material approaches but does not touch the neutral material. The result is that the neutral material has the electrons and protons rearranged, forming a dipole, but it still has a net zero charge. So right here is actually a really good summary of all of our different charging techniques. If we're looking at friction, both materials are neutral before you charge it. The charging process is both items are rubbed. One item becomes negatively charged, one item becomes positively charged. In conduction, I have a charged item and a neutral item. The charged item touches the neutral item, and the result is that they share that charge. And my last, in induction, I still have a charged item and a neutral item. The charged item is brought close to the neutral item, but not touching it, and then I get a rearrangement of the electrons in the neutral item and the same charge in the charged item. Okay, so to end up our discussion on static electricity, it's just basically to talk about our three categories of materials. So conductors are any materials that allow for electrons to go through it. So those are going to be your metals and electrolytic solutions. Again, an electrolytic solution can be an acid, a base, or a salt because there are ions that are dissolved in the solution. Insulators are materials that prevent electrons from flowing. So these are usually nonmetals, plastics, glass, and wood. They tend to not give up electrons very readily. And then my semiconductors are basically materials that sometimes allow electrons to flow depending on different factors. And very common semiconductors would be things like carbon and silicon. They're used a lot in electronics because you can actually control when the electrons flow through them and when they don't. So I hope this helps, and I hope you have a great day.